Hello, good people. Have you ever watched Star Wars? Have you ever seen the scene with Han Solo bragging about how his ship can make the Kessel Run in 12 parsecs? Many lovely internet users love to point out that that is actually a unit of distance and not a unit of speed. This is actually correct. A parsec is a unit of distance and not a unit of speed. In the scene, Obi-Wan asks Han Solo if he has a fast ship, and Han Solo responds that it made the Kessel Run in 12 parsecs, which makes you think that he's talking about how fast it goes, because that's what Obi-Wan asked, was it a fast ship? And movies like to do this quite often, right? They like to throw in words to make it sound really cool. It's like saying that you can run the 100-meter dash in 80 meters. And that's kind of strange, don't you think? However, I doubt this is what George Lucas meant. And he probably just put it in there to sound cool. Disney actually tried to fix this in their movie, so that the way Han Solo described 12 parsecs was actually a feat of accomplishment. What they did is that most people have to travel this crazy path through a bunch of junk in space, and that makes the usual distance that they have to travel 20 parsecs, whatever it was. And Han Solo, because he was an amazing pilot, was able to do it in 12 parsecs by skipping over the usual path and going through dangerous, hard things to go through. But honestly, that doesn't speak to how fast the ship is. That speaks to how skilled of a pilot you are, right? At least that's what I would think. But I digress. The real point that I want to make is explaining what a parsec actually is. Why can I tell you about parsecs? Well, it's because parsecs are in fact something that I use quite often. I do research into galactic distancing. I try to distance galaxies, and I try to make very accurate distances. And these distances are very far away. Very, very far away, in fact. To give you an idea of what a parsec actually is, I'm going to have to explain a few things. The first thing that I'm going to go over is called parallax shift. And it has to do with how things shift in the sky when you look at it at a different angle. Take your finger and hold it out in front of you like this and stare at it. Now, look at something in the distance. You are actually viewing your finger with two eyes, and your eyes are viewing your finger at two different angles. And so, if you look at something far away, something close to you will appear two different times in your vision. If you can measure the distance between the two images that you see with your finger, you can measure how far away your finger is from your face. Now, of course, that would be kind of complicated trying to do that. The point is that you can measure distance if you can see something shift in the sky due to viewing it at a different angle. And this is what parallax is. The second thing that I have to go over is how astronomers locate things in the sky, and to explain this part, it will be easier if I actually draw it, because there's a lot of parts that I don't know if I could explain just by talking about it. So here we go. So imagine that you are looking up at the night sky, and you have to come up with a consistent system where you can be able to relocate a star regardless of what day it is or what time of the year it is. Now, if you think about it, the night sky is constantly moving, right? That's why we have rising and setting stars. That's why the sun rises every morning, is because the Earth is spinning. And the stars do the same thing. If you look, some stars will rise every single night while some stars are setting. And so astronomers decided to use the same system we use to keep track of time, because if you think about it, if I say it's 6 a.m., you know that the sun is likely rising. If I say it's 6 p.m., you should know that it's probably pretty close to setting. And so we've divided the sky up into 24 arc hours. Now we call them arc hours because they are connected very close to our time system. If you wait 1 hour, the sky will shift by 1 arc hour. Now, having an entire hour in the sky is a pretty large chunk of the sky. So in fact, astronomers did the next logical thing was, let's divide each arc hour into arc minutes. And if you can guess how many arc minutes they put into an arc hour, they put 60, of course. And in fact, they went even finer than this. They said an arc minute is still too much. And so guess what happened next? They divided each arc minute into arc seconds. Now, going on from that, the other part of the definition is how far away we are from the sun. And I'll draw the sun here. I drew it yellow, and let's put a blue Earth because Earth is mainly blue from all the water that is currently on the Earth. And we've defined the distance from the sun to the Earth to be exactly 1 astronomical unit. So if you traveled in a spaceship from Earth to the sun, you would have traveled 1 astronomical unit. Now, if you then take out your camera, your telescope or whatever, and let's say your telescope, that each pixel can fit 1 arc second of the sky on it. And your star is on the left side of your detector. You take this picture, and then 6 months later, let's go back to the sun picture, you let the Earth go all the way around its orbit to the other side of its orbit, and you decide, okay, I'm going to take another picture. And that second picture will actually do something really cool. Your star will have moved 2 arc seconds over if the star is 1 parsec away. This is because of parallax. And when you take 2 pictures, one on one side of the orbit and the other at the other side of the orbit, your position has shifted by 2 astronomical units, and you are taking a picture of the star at 2 different angles. And we've defined a star to be 1 parsec away in distance when it shifts 1 arc second in the sky when you move your position by 1 astronomical unit. And all those together define a parsec. Now it seems like a complicated way to define a parsec that way. And to be honest, it kind of is a little bit complicated. But think about it. If I told you that a star is 13 trillion kilometers away, what does that mean to you? When I make measurements, it's in megaparsecs. That would be like adding 20 freaking zeros to your kilometer measurement. That would make no sense. And I wouldn't really get it. Nobody would really understand it. It's a number that's too big. But you can understand different times of the year. And you can understand that the Earth is moving around the sun. And, in fact, it's a little bit easier to understand how far away the sun is because we can build things that can reach the sun. And so if you take your unit of distance and you relate it to things that we can understand, it makes it easier to understand what that distance means to us. Now, is it still incomprehensible how big space actually is? Of course it is. It always will be. Space is so massive that you will never really truly be able to comprehend it. If you are curious about more things in space, just let me know in the comments. Like, I would love to get ideas or any suggestions on what you want to hear next. Comment it down below, and I'd love to see what I can do to get you guys a little bit more knowledgeable about things in space. And thank you for listening. Thank you for watching. And and we will see you later. Thank you.